everyone, and welcome to lesson 31.1. Today's lesson is going to start on page 447 in your Springboard textbook. You're going to want a pencil and a calculator handy, as well as possibly a sheet to keep track of the formulas for this section. Now on page 447, we see a couple of vocab words highlighted here. The first is a polygon, and a polygon is a closed geometric figure with sides formed by three or more coplanar segments that intersect exactly two other segments, one at each endpoint. Basically, a polygon has to have straight sides and they have to connect in, and we kind of start with our first type of polygon is a triangle, and then it kind of goes on from there. I mean, we can have any sides, but basically kind of our minimum size is the three-sided triangle. Now, there are angles officially on the exterior. If you were to extend this out, these would be the exterior angles. If we extended out these segments, this would be exterior. But our focus in this lesson is going to be our angles on the interior of our polygon, right? We have all kinds of angles inside of the polygon, and those are known as our interior angles and will be the focus of this lesson. Now, on page 447, we see a couple of figures, right? We have a triangle, we have a quadrilateral, and we have a pentagon, right? A five-sided figure. Now in our triangle, we know from way back when in unit and first semester that there are 180 degrees total in this triangle when we add up the sum of these angles, right? No matter what size they are, they will add up eventually to be 180 degrees. Well, if we look at the quadrilateral, we want to look at, if we draw in a diagonal in here, how many triangles can we create? Well, currently we can control without crisscrossing any others. We can draw across here and we create two triangles. So this triangle would have 180 degrees total and the interior angles. This would have 180 degrees in that one. So the quadrilateral has a total of 180 plus 180, or 360 degrees. Same thing, idea with going on with this pentagon. If we start drawing in, this time we create three triangles. And again, each of them have 180 degrees in them. So the total amount for the pentagon would be 540 degrees. And this pattern is going to continue on the next page as well. We have another quadrilateral. Again, we have two total triangles. Each of them we know we proved last semester have 180. So again, total is 360. Same thing with the triangle. We knew there was 180. Proved that last semester. And again, another pentagon proves to us, again, another 540. So we see a consistent pattern that all the triangles have 180 degrees, all the quadrilaterals have 360 degrees, and all of the pentagons have 540 degrees. So each time there's a pattern involved. And if we move to page 450, we can start filling out this chart to kind of see what's going on. Now, if we move on to a hexagon, okay, and a hexagon is a six-sided figure. So I'm going to have one done. There's our hexagon. And if we continue with this conjecture, can we create more triangles? This time we are creating four. 1, 2, 3, 4. So 4 triangles, aka 4 times 180, for a total of 720 degrees. Right? And happening probably then with a heptagon. If we moved on to that one, a 7-sided figure, we would see the same thing. We could draw in more and more and more triangles. So what we're seeing is we continue moving on this pattern. We have hexagon is 6 sides, heptagon is 7 sides, octagon is 8, nonagon is 9, decagon 10, dodecagon 12. Or as we get beyond 12, we usually just start calling them n-gons. So we'll just have n for n numbers. What we're seeing is we saw that this was 180 degrees, 360 degrees, 540 degrees, 720. Basically, each time we're noticing a pattern that we're kind of adding on 180 degrees, right? And we could kind of keep moving on down here. Now, think about, again, if we're going by based on triangles, we know that there's 180. And there's only one triangle possible, so we use the number of sides minus 2 to get 1 times 180 to get 180. And then we need to do the same thing here. We have 4 sides, but we need to make 2 triangles. Got a number of triangles times 180 is the total degrees. So 2 times 180 would be the 360. 5 times, well, we don't need 5. We only need 3 triangles created. Oops, so we'd have to subtract 2. So we kind of see this pattern each time that we're consistently subtracting away 2 from the number of sides to get our total number of degrees. So we see this pattern would continue. 7 minus 2, oops, not 8, 2, and then times the 180 to get our next value, and so on and so forth. AKA n minus 2, the number of sides minus 2 times 180 gives us the sum of the interior angles, right? This is kind of our big formula of the day, that the sum of the interior angles is this, so the total sum. Okay. Now, moving on from there, we want to look at some practice problems, okay? So we're actually going to skip over this page here, and we're going to jump to page 452 to get our some practice in with this, okay? And we're going to look at number 16. So number 16 says we want to figure out the sum of the interior angles of a 20-sided polygon. Well, that means the number of sides is 20. And again, our big formula of the day is the sum of the interior angles is n minus 2, the number of sides minus 2, times 180 degrees. So we're going to use this to help us figure out the 20-sided polygon's sum, right? So the sum of the interior angles is going to be, in this time, 20 minus 2 times 180. So 18 times 180 is going to be 3,240 degrees. Now, what happens if we look at number 17? What is the measure of each interior angle of a regular polygon with 60 sides, right? 60 sides. Well, n is 60, that means, on this one. Well, when we talk about each interior angle, we're just talking about one angle. And if a polygon is regular, that means that it has the same size sides and specifically angles, okay? So basically what we're saying in number 17 is we have a total of 60 sides. So if we look for the total sum of the interior angles, it would be 60 minus 2 times 180 degrees, okay? But we want to figure out what each individual side is. So we would have 60 minus 2 times 180, but we want just what each of those 60 sides are, so we need to divide it up evenly between the 60 same size sides, so it would be 174 degrees. So really what we're doing is we're dividing this then by the number of sides to get our final answer of 174 degrees, okay? Last but not least, we want the sum of the interior angles is given to us. This time it's 2,340 degrees, and we want to figure out how many sides it has. So this time, when we're looking at the formula, they're actually giving us the total sum. They're giving us this value right here. The sum is 2,340, and we want to find the value of the number of sides, which is this value of n. Well, you have two options. You could distribute this first, but instead of distributing, it's probably a little bit faster to get rid of the 180 first, right? Kind of like we used to multiply by the 1/2. This time, if we divide by the 180, we can get rid of that first. So we're going to take the 2,340 divided by 180, and we get 13. Now, you are not done because 13 equals this n minus 2. So to get n completely by itself, we need to add 2 to both sides for a total of 15. Now remember, you can always check your answer. Is 15 minus 2 times 180 2,340? Yes. Let's say you forgot to add the 2 back in and you tried to test your answer, you would notice that this is incorrect, right? This is not the same answer. So you would have realized, uh-oh, I did something wrong. Okay, so make sure you add that 2 at the end to find your total numbers. Thanks everyone for watching, and we will work more with this in class.